Hi, this is Year 12 Pure, Chapter 10, Lesson 5, and today we're going to be solving some harder trigonometric equations. Now, what I mean by harder trigonometric equations is something where you've got an adjustment being happening before the trig. So the trig has been applied to some function. So not things where we've got, say, cos of x, things where we might have cos of 2x, or we might have sine of x plus 30. So something happening before the trig has been applied. Now, when we're dealing with something like this, the first thing to do is to note that you've got cos of 3x equals 0.7. There we have 3x, and so our interval, if we were talking about 3x, would be 0 up to 1080. Okay, 3 times 360 is 1080. And so essentially what I want to do is find out all the values between 0 and 1080 that work. And then from there, I'll try to find out all the values if it was just x we were talking about. So what we'll do is we'll say, well, I've got 3x is equal to the inverse of cos of 0.7. And I can tap that into my calculator and I'll get 3x is equal to a particular value. So tap it into your calculator, shift cos 0.7, and you get 45.47. Okay, 45.47 degrees. Now, if you were to do this wrong, what you would do now is to divide by 3 and then find out a bunch of other values. That's not the right way to do it. What we need to do is to find out every other value that casts all the way up to 1080, so that's 3 full rotations, and then after that we're going to divide by 3. The very last thing we do is to divide by the 3. So we're going to take 45.47, C, A, S and T, and because we've been talking about cos and cos is positive in this quadrant, cos will also be positive here, so we have 45.47, and so this will be 314.53. And then after that you're going to get 360 plus 45 and 720 subtract 45, and then 720 plus 45 and 1080 subtract 45. What you'll note though is that they're actually on the next 2 full rotations, so I can just add 360 to this, add 360 to this, and then do the same again. So adding 360 to this will be 405.47, and you'll get 674.53, and adding 360 to this will be 765.47, and adding 360 to 674.53, 674.53 plus 360 is equal to 1034.53. So we got 1034.53. Those are all 6 values that would work if we were dealing with 3x, but we're dealing with just x. And so all we need to do is take each of those and divide them by 3. So we get 45.47 divided by 3, and that will equal 15.16. And then we'll do a similar thing for all of the other candidate values. Okay, and so there will be a total of 6 values by the end, all of which will work. Okay, all of which will work. Now the critical thing that you must note is once you apply that inverse cos, then you have to find every single candidate value before you start undoing bits within that function there. Okay, so let's move on to this question. We have solved the equation 5 sine of 2x equals 3 cos of 2x in the interval negative 180 up to 180, and this sometimes people find a little bit more difficult, and so negative 180 up to 180 for x would be negative 360 up to 360 for 2x. Now we have 5 sine of 2x is equal to 3 cos of 2x, and you should know that what you can do with this is you can express it as sine of 2x over cos of 2x is going to equal, so we've moved that under 3/5, and so tan of 2x is equal to 3/5, and so 2x is equal to inverse tan of 3/5. Okay, And so what we'll do is we'll find out all our candidate values for 2x. I expect there to be 4. We'll need to do cast to make sure. So we've got inverse tan of 0.6, 30.96. Okay, so we use inverse tan of 0.6, which is 30.96 is your first value, and then we can cast it. C, A, S, and T. Okay, and so we've got 30.96 here. So in our first rotation forward, so going up to 360, we go past 30.96, we go to 180 plus 30.96, which is 210.96. Going back to negative 360, we start at 0, negative 90, and then we've got negative of whatever this is. Okay, so a negative value of whatever this amount is, which would be 180, would be there, take away 30.96. So not quite getting to 180. So you've got 180 take away 30.96, which comes out as 149.04. And so we're going back by 149.04, so negative 149.04. So we're going back by 149.04. To get this value here, when we're going back, we're going back. Okay, we're not quite going 360. We're going 360 take away 30.96, which is 329.04. But we're doing that going backwards. Okay, so we're going back by 329.04. Okay, so those are the 4 candidate values there. Now once we've got that, we can divide through by 2. 15.48, 105.48, 74.5, negative 74.52, and 329.04, 329.04 divided by 2 is 164.52, so negative 164.52. Okay, those are all the solutions in the interval. Remember, you need to come to a solution first, cast, and then deal with this inside function here, the thing that cos, sine, or tan was applied to. Okay, this question's more difficult. The reason this is more difficult is that you've got a very, very, very awkward part there. Really awkward, 2x plus 30. It's actually the pluses and the subtracts that are much more difficult than the multiplication. Okay, so what we'll do first off is we'll say, well, sine of 2x plus 30 is going to equal 0.2, and so 2x plus 30 will equal inverse sine of 0.2. Now the interval that we're going to be dealing with is 2 lots of 0 is 0, plus 30 is 30. 2 lots of 360 is 720, plus 30 is 750, and so I need to find all of the solutions that fit within there. Okay, so we have 2x plus 30 equals, now we've got inverse sine of 0.2, which comes out as 11.54. Now actually that happens to be not a suitable candidate, but we need to use it for our cast and then cancel it out later. So we've got 11.54 C, A, S and T, and I want to go up as far as 750 degrees, so there's quite a lot going on here. So we've got 11.54 here, 11.54, so that's going to be 180 subtract 11.54, 180 subtract 11.54 comes out as 168.46. Okay, and the next time that this line is going to be used is on the next rotation. So it's 360 plus this, which is going to be 371.54, which is fine. Add on 360 here would be 468,528.46. Add on another 360, and we're going to end up with 731.54. Add on another 360, and you're going to end up with 888.46. Now, this falls outside of the region. This falls outside of the region, and so we just want these ones. All we do now is if we say 2x plus 30 is equal to 168.46, 371.54, 528.46, and 731.54, we can subtract 30 and then divide through by 2. Okay, so subtract your 30 and divide through by 2 and find out what you get. Okay, so those are your values. You got 69.23, 170.77, 249.23 and 350.77 degrees. Each of those work. Think about it. Is it checkable? What could you do to check it? Well, a good way to check it, a really easy way to check it, would be to take one of these values, plug it in up here, multiply it by 2, add 30 to it, apply sine to it and multiply it through by 2, and see if you get something that's close to 0.4. Why is it only going to be close to 0.4? That's one thing to think about. So let's try checking one of them out. I tend to pick one of the ones that's not the first one. So we'll go with 2 sine of 2 times 170.77 plus 30. And we'll find out what that comes out as. So we get 2 sine of 2 times 170.77 plus 30. Comes out as 0.40010400046. So it actually comes out as 0.40010. Okay, and so we were really, really, really close. And the reason that we were only really close is because we rounded all the way back up here. We were rounding here, so we get something that's really close, and it's okay for it to be close. Right? So here's an exam question. This is from June 2010 from a C2 paper. I'd suggest pausing the video and giving it a go. Alright, so let's see if you manage to do anything decent with it. So we've got, given that 5 sine theta equals 2 cos theta, find the value of tan theta. Well, this is pretty easy. You're going to get sine theta over cos theta. So we're moving that under, so we get 2/5. So tan theta equals 0.4. That'll do. Okay, there's 1 mark. What a treat, easy 1 mark. Next, solve for 0 to 360 for x. Pretty much the exact same equation, except theta has been swapped for 2x. And so we've got 2x, so that's going to take us up to 720. 2x is going to take us up to 720. So all I need to do is basically solve this up to 720. So we get tan of 2x equals 0.4. 2x is equal to inverse tan of 0.4, and then we can use inverse tan of 0.4, which is equal to 21.8, because we want 1 decimal place. So 2x is equal to 21.8, and we're going to be casting up to 720. C, A, S, and T. Tan is positive here, tan is also positive here, so we get 21.8. 180 plus 21.8 will be 201.8, and then we can start adding on those 360s. So add on 360 here, you get 381.8, and add on 360 here, which is going to be 561.8. We just then need to divide through by 2, so x is going to equal, well, 21.8 divided by 2. 21.8 divided by 2 comes out as 10.9. You'll get 100.9. You'll get 190.9, and you'll get 280.9. Alright, those are the answers to 1 decimal place. Hopefully you got the exact same thing as me. Thanks very much for watching. Good luck.